Today, I only have 2 riddles for you, but it means that you're not going to crack them easily. Prepared? Here's the first one. Far, far away from any civilization, there is a remote island with 20 inhabitants. They were born there, and all their lives they've been into math, which helped them become pretty perfect logicians. Unfortunately, they're imprisoned, being trained to win the Nobel Prize, and they can't leave the island. Well, actually, there's a way. Each islander can approach a guard at night and ask to leave the island. If the islander who asked to leave has green eyes, they will be allowed to leave. If not, they'll be tossed into the island's volcano instead. So, obviously, no one takes the risk because none of them knows their eye color. The thing is that all of them actually have green eyes, so each one could theoretically leave, but, well, none did. They don't have any reflective surfaces, they're mute, and they're not allowed to communicate with each other in any way. The only time they all see each other is during the lineup every morning. One day, I got the privilege to travel to the island and present myself during the lineup. I could make an announcement, but there was one strict rule. I couldn't tell them any new information unless I wanted to be thrown into a volcano. But I really wanted to help those guys out, so here's what I said. At least one of you has green eyes. How many days will it take all of them to leave the island after my announcement? Okay, maybe 20 is a bit hard to figure out right away. So let's first consider the case of 2 islanders, Etta and Phi. Both of them have green eyes, but they don't know their eye color. So the day when I announce the statement, they pay attention to it and look at each other, remembering the eye color. Etta sees that Phi has green eyes, which aligns with my statement, but she can't be sure that she has green eyes too. Phi does the same. She sees Etta's green eye color, but he isn't sure about his own eye color. So the night comes and none of them leaves. When they both see each other the next day, they realize something. Etta realizes that if Phi had seen that she didn't have green eyes, he would have understood that the one person with green eyes was him and would have left the island that night. But he didn't do it. So Etta realizes that Phi saw her green eyes and wasn't sure about his eye color. So her eyes must be green. Phi has the very same logic and figures out that he has green eyes too. So now they both know it, and the second night they both leave. In the case of the 2 islanders, they both left the second night. Now let's say there are 3 people on the island, Etta, Phi, and Theta. Each of them sees 2 green-eyed people, but they still can't be sure about their own eye color. So no one leaves the first night. In the morning, they see each other again, but unfortunately, none of them are sure again. Theta thinks that possibly her eyes aren't green, and Etta and Phi were watching each other. She figures that now they will both see that none of them left and will leave the next night. Each one of the 3 thinks so, and once again, no one leaves. The second night passes, and the 3 islanders meet the third morning. So, Theta is now sure that Etta and Phi weren't just watching each other, but her too. So she must have green eyes. Etta and Phi, who were following the same logic all the way, realize the same thing. So all of them figure that they have green eyes and leave on the third night. Now, if I add another islander, the same logic will work, and it'll take one more night to figure it out. In our case, there are 20 islanders. They will all see 19 green-eyed islanders and will all wonder if others see 18 or 19 green-eyed islanders. So they will watch each other for 19 nights, and when they see each other on the 20th morning, they will all leave on the 20th night after that. Okay, great job. Here's the second riddle. This one is much easier in my opinion, so I'll give you a little break. But you still need to keep your brains turned on. You take a voyage across a sea, delivering fish tanks with rare species of fish to scientists who will work on increasing the population of that said fish species. But on your way, you get into a storm, and the fish tanks get drowned in the sea. The records get lost too, so you're not even sure how many fish tanks there were to start with. Still, you must find them all. Good news! There's a rescue submarine you can use, but there's only enough fuel for one trip to the bottom of the ocean. So, before going down, you make some inspections. Thermal imaging detects 50 organisms in the areas where you have lost the fish tanks. Those are your fish and sharks, which are not yours. Using a scanner, you scan 3 regions of the sea more closely: Region A, Region B, and Region C. The scanner shows that in Sector A, there are 4 fish tanks and 2 sharks. In Region B, there are 2 fish tanks and 4 sharks. Just as you're about to scan Region C, the scanner breaks down and doesn't show you anything. So, you need to figure out how many fish tanks there are to send to the submarine. This is not an easy task, especially with lost records. You don't know exactly how many fish tanks were on board, but you remember that there were no more than 13 of them. You also don't know how many fish there are in each fish tank, but you know that it's the same amount in each one of them. There's also information that in every sector there's a different amount of sharks, and not more than 7 in each one of them. Knowing all this, can you figure out how many fish tanks drowned in Sector C? The best way to solve this kind of problem is by using a table. So, we know that there are 13 fish tanks at most. 6 of them were located in Sectors A and B, so there are between 6 to 13 fish tanks in total. Can't be more, can't be less, since we already have 6. Now, let's move on to the sharks. In each sector, there are no more than 7 sharks. Also, there's never the same amount of sharks in 2 regions. Since regions A and B have 2 and 4 sharks, the possible number of sharks in region C is 1, 3, 5, 6, and 7. Let's put these numbers in the rows. In a column next to it, we put 6 in each row. That's the number of sharks in regions A and B. Now we know that there were 50 creatures located in the waters. So for each possible amount of sharks, we can calculate the remaining amount of fish. 43 in case of 6 sharks plus 1 in region C. 41 in case of 6 sharks plus 3 in region C. 39 in case there are 5 sharks in region C. 38 if there are 6 sharks there, and 37 fish in total if there are 7 sharks in the last region. Okay, now we have to remember that the number of fish is the same in every tank. So, the total amount of fish must be divisible by one of the possible values for the total amount of fish tanks. 43, 41, and 37 are prime numbers that aren't divisible at all. In case of 38, we'd need 19 tanks, 2 fish in each, but we know that the maximum number of fish tanks is 13. So the only possible scenario is 39 fish in 13 tanks, meaning 3 fish in each tank. So, in Region C, 7 more fish tanks got lost on the bottom of the sea. I hope you can find them all now.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.